today, doing all of chapter 2. And I hand you a chapter 2 quiz for take home. Next class, we're going to do the chapter 2 test.
Oh.
Chapter 2 is essentially algebra 1.
Oh.
So like, this should be old hat. We'll go through, run through, and do some examples. It's not new. It's all review. Should be easy. If it's not easy, ask some questions and make sure we get clarifications in. But this should be a nice break from last chapter, which was considerably more conceptually difficult, to something that should feel very familiar and not new. So just running through a little bit of vocabulary. When we say what is a solution? It's a value that satisfies an equation or an inequality, right? Value or values. We're talking about polynomials. We could also use the word root kind of interchangeably with the term solution. Talking about the same thing. What's the difference between a solution and a solution set?
How many of them there are?
Yeah, sure, good enough. How many of them there are? An identity. What do we mean by an identity in mathematics? It's a statement that's always true, right? Give me an example. Okay. Sure, 1 equals 1. How about one from trigonometry? Very disappointed. I'll start. Sine squared.
Plus cosine squared equals 1.
Excellent. Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. Okay. Another example might be from geometry. A squared plus b squared equals c squared, assuming that a, b, and c are side lengths in a right triangle where c is the hypotenuse. Yep. Everybody's okay? What we mean by an identity? Hi Sam, what's up?
Yeah, talk later afternoon.
Sure. Make sure you bring it back. Okay. All right. And then a formula. Similar to an identity, but typically will be describing like a specific situation. So Pythagorean theorem you could think of as a formula as well. All right, so a couple quick example. So what if we're given an equation and asked to solve for a variable? So in the first one it says we have a squared plus b squared equals c squared. We want to solve for b. What do? Okay. Then what?
Square root.
Okay. And then what does that give us?
It's
What do I get? I heard some mumbling, but it wasn't clear. So Nicole said to square root both sides, which is great. So what do I say? Then b equals what? Wrong. Very wrong.
The square root of c.
Still wrong. Super wrong. Yours is partially right, but still wrong. Very disappointed. Plus or minus c squared minus a squared. Square roots do not distribute across addition or subtraction. The square root of a squared minus b squared is not a minus b. Wrong. Very wrong. Forgetting the plus or minus, still wrong, not as wrong though. All right, what about, let's do C. We're solving for R. What's the complication there? Why is solving for R going to be a little difficult? It's in two separate locations, right? Great. To be able to solve for it, how many locations can it be in? One. So first step I would do is, what do you think? Nice.
So we need to divide by R.
Divide by R?
Yeah.
I want to do like this.
Yeah.
You do that, I guess. Is that better than before? They have fractions inside of fractions now. Right? Like, you can do that, not wrong.
Yeah, but.
Like, you can get to the right location, you haven't done anything illegal. Other than the possibility that if what happens if R is 0,
Yeah.
then you just divide by 0, and that. I wouldn't multiply by R. What I have is a proportion. So I'm just going to cross multiply. So I can say that. I get rid of my fraction. That's probably helpful. Now what? Are the R's in the same location yet? Two different spots. What should I be working towards? Getting them in the same location.
Yeah.
So ideally the same side of the equation for starters, right? Okay, what do I need to do then? Yeah, I love distribute the I. Now what? What's that?
Don't want to divide by R.
No, you'll be,
No, subtract.
subtract what?
R.
Yeah. So let's move those guys over. What's NR minus RI? Okay. That's fine. So you just write them next to each other. What's that?
Don't you do all that stuff?
We're almost there. 3 letters. G, C, F. What is that? What should you do?
Greatest.
Take R out.
That's it. What does that accomplish?
Yeah.
It gets R into
So.
one location, right? And the last step would then be just to divide by n minus I. And you're done. Assuming that, your variables don't make a 0 denominator anywhere. All right. Linear equations. The defining characteristic of any linear equation is slope. What's the equation for slope? That's the equation for a line. Y equals mx plus b. Slope is rise over run, or y2 minus y1 over x2 minus x1. Right? It's on the board. Okay? So, different ways that you can write the equation of a line. So you have the general form, like ax plus by equals c. The catch there is that the a, b, and c must be integers. So if any of them are fractions, what do you have to do? Multiply both sides by some constant to get rid of the fractions. There's y equals mx plus b. For our textbook says c, I don't know why. And then the point slope form, y minus y1 equals m times x minus x1. Probably the most useful version because basically plugging stuff in. And then to remember, if you have a horizontal line, that's always going to just be y equals some constant, or a vertical line, x equals some constant. Both of these are technically general form equations. All right. Do we need practice graphing lines?
No.
Okay, I'm going to skip that. Find the equation of a line that passes through the point 3, 1 and has a slope of 12, right in slope-intercept form. The textbook says the word gradient. That's just slope. What do I do?
Just use 12x plus.
When we start here, since you're given a point and a slope,
Yeah.
and then we can just rearrange. We add the 31. That's probably the easiest way to approach it, right? If you're given a point and a slope, use the point and slope form and then rearrange to get whatever it asks you to form you want. Let's start with the form that's easiest to write. It says find the linear equation in C and F, knowing that when C is equal to 10, F is equal to 50, and when C is equal to 10 or 100, F is equal to 212. Solve for F in terms of C. Linear equation, right? F in terms of C means that like F is my y coordinate and C is like my x coordinate. So what am I going to do with C equals 10, F equals 50? Just like a point, right? Same thing with that guy. Is everybody okay with how I interpreted that from the words?
Yeah.
Okay, what next? How am I going to get an equation? It says linear equation. What should I be doing? What do I need to do first? Got 2 points. And I have to find the slope. How do I do that?
Minus y2.
Right? So what is that going to be? 62 over 90. Can that reduce? Yeah. So 81 over 45. I can take a 2 out for sure. Can that reduce? What can I take out of that? 9, right? Can that reduce? Okay? So then we'll say y minus y1 equals m times x minus x1. What's 9/5 times 10? 18. And then we add the 50 over. Anybody recognize that? What is it?
It's y equals mx plus b.
No, that formula.
Slope formula.
No, specifically.
Slope intercept.
It's the conversion formula from Celsius to Fahrenheit.
Oh.
Should be able to pick that out just by looking at the points.
Yeah.
Specifically, what point is the giveaway? The 100, 212. The boiling point of water in Celsius and Fahrenheit. Scientists in the room. Good gravy. Parallel and perpendicular lines. What do we know about parallel and perpendicular lines with regard to their slopes?
Parallel has the slopes, and perpendicular is the parallels.
Perpendicular opposite reciprocals. One little caveat though, where do those things kind of fail? Kind of gets weird for vertical and horizontal lines, right? Vertical lines are parallel, even though they have no slopes. Horizontal lines, parallel. And then horizontal and vertical lines are perpendicular, even though their slopes are not negative reciprocals, because you have 0 times infinity, basically. Is everybody okay? Let's look at this example. We got line y equals 3/5 x plus 2. Find the gradient and the y-intercept. What's the slope? 3/5. What's the y-intercept? So I would say it's the 0.02, right?
Oh.
Everybody's okay with that? I don't think they'd mark you down if you just said it was 2, but I think technically the y-intercept should be a point. It says find the equation of a line that passes through the point 1, 5 and is parallel to the line. What does the slope got to be?
3/5.
And the point is 1, 5. So if I just use my point slope, I can say that, right?
Yeah.
And if I ask me for a specific equation for a line, I can rearrange from there, but if it's not specific, I'm stopping, right? The directions don't ask for something specific, probably doing everything as a point slope. C says same thing but perpendicular. What's different between parallel and perpendicular?
Opposite.
So the slopes are opposite reciprocal, so the slope here for perpendicular should be -5/3. Still have the same point, still do everything else the same way. Again, the directions asked for a specific type of equation, I would do some rearranging from here, but if it doesn't, I stop, I'm done. Everybody happy? Okay? Next example, L is given by the equation 3y plus 2x equals 9, and point P as the coordinate 6, -5. Explain why P is not on the line L. Guys, what do we do here?
We take out the coordinates from the equation. It's all from there.
No, man, way easier.
Get Y minus.
Way easier. Done. I plug the point in the equation, I should get 9 if the point's on the line, right? I plugged in, I got -3. Bang, 9. Done. Easy, right? Again, a point has to satisfy the equation for the line. The point's not on the line, doesn't satisfy the equation. Easy peasy. If I want the slope for L, how am I going to do that? Well, we want to get the y by itself, right? And in doing so, I'm going to end up in the slope-intercept form, right? Okay? Easy peasy, right? Algebra 1 stuff. It says write down the gradient of a line perpendicular to L. What's that going to be?
Positive gradient.
Yes. And what if I want it to pass through that point P? Right? There's an equation. Again, it's not specific on the form it wants it in. I'm stopping here unless it asks me to do something different. Everybody okay there? Okay. Solving systems of linear equations. So in Algebra 2, you would have talked about solving these by graphing, possibly with technology using your calculator, substitution, elimination, technology without graphing. What do we mean there? Using a matrix and just doing that RREF command. You guys remember doing that in Algebra 2? What a time saver that is, right? When we talk about the solution of a linear system, there are 3 possible solutions. The 2 lines intersect exactly once. You get 1 point as a solution. They intersect infinitely many times when the 2 lines coincide. You get infinitely many solutions. Or they don't intersect at all, where the 2 lines are parallel. Is okay there? That's assuming that we're operating in 2 variables. So here's 3 pictures of what those solution sets would look like from a graphical perspective. All right. Let's use our calculator to solve. We'll just do one of these. If you have your calculator with you and you'd like to follow along, I invite you to take that out and do so. If you're like, I'm just going to sit and watch, that's super cool too. All right. Let's use a matrix to do this. First thing I need to do is translate that system of equations into a matrix. How do I do that? This is without the calculator. I'm not talking about where on the calculator. How do I translate that system into a matrix? It's very easy because it's already set up in a very nice way for us to do this quickly.
Do you include the equal sign like after, so like the 6 and the -10?
So what you do is you make sure that the x's, the y's, the equal sign, and the solution is all lines up vertically with one another, which I do in this case, right?
Yeah.
So my matrix is going to be a 2x3 matrix. I'm going to have 2 rows and 3 columns. The first column will be the x's, the second column will be the y's, the third column will be the solutions. So I'm going to type that into a matrix. So I'm going to press second and the matrix button on my calculator. I'm going to scroll over to the edit tab. I'm going to pick one of my matrices to use. I'm just going to use matrix A. I'm going to, as I said earlier, this is a 2x3 matrix, so it's rows first. I have 2 rows because I have 2 equations. And then 3 is the second component is the columns. I'm going to have 3 columns because I have column for x, y, and solution. And then I just type in basically as it looks like on my sheet of paper. Keep in mind that negative y means that you have a -1 there. If you just have the variable, there's always a 1 in front of it. Probably don't need to say that, but we'll say it anyway. Does everybody feel good so far as how we got that into the calculator? Okay. We exit out of here, boom, boom. We go from the home screen, we're going back to the matrix menu, but this time we're going to the math tab. We're going to scroll all the way down to the bottom till we see the RREF command. Make sure you pick the one with 2 R's. That stands for row reduced echelon form, if you care. You probably don't. And we're going to do that command on that matrix A that we just built. And I'll press enter. So the way I read that is the first row of my matrix says that 1x plus 0y is equal to -3. So just x equals -3. The second row reads 0x plus 1y is equal to 4. So y equals 4. So my solution is the point -3, 4. Everybody feel, jog your memory as to how to do this on the calculator? Again, fairly easy. You've done it before. I don't want to belabor this. Let's do an elimination to solve this system. Just reviewing methods here. So how do we do elimination?
You have to make it, like multiply the top one by 2 and the bottom one by -1.
Great, so I need to multiply each equation by some coefficient so that when I add the 2 equations together, one of the variables is going to cancel out. So Lucy says we can cancel out the x's by doing this, right? You could have also instead canceled out the y's by multiplying the top one by 4 and the bottom one by 3. Either is fine, it doesn't matter. And then we'll just add down. So far, so good? What do I do with that y equals -2 now?
Plug it back
Plug it back in where?
to either equation.
Any equation that has x and y in it both, right? Could be this one, could be this one, could be this one, could be this one, doesn't matter. Which one would be the best one to choose though? I'd probably pick this one because the numbers look the smallest to me, but it doesn't really matter. You may. I feel all right. Okay. Cool. Let's do substitution to solve this next system. To do substitution, what do we need to do first? You need to get one of the variables by itself. So one of the equations starts either x equals or y equals. Which one it looks like it's going to be the easiest? The top one. And which variable do you want to get by itself? The y. Why did you choose that? I would agree.
Yeah, it doesn't have a number.
Because there's no coefficient on the y, that makes it the easiest. Because when you divide, you don't have to divide. You won't make any fractions. Because typically those are our enemy in this kind of thing. It just makes things more difficult than it needs to be. So I'm going to add y to both sides and then add 9 to both sides. So I get 3x plus 9 equals y. You could have subtracted the 3x from both sides and then divided by -1. That's fine too. I just typically try to avoid division if I have to. Okay, once I've done that, what do I do next? I plug that equation in for the y, right? So there I get x equals -4/3. What do I do with that then? I would plug it into this one since the y is already by itself.
Okay.
But any equation with both x and y in it is fine. It doesn't matter. So those guys cancel out, so I have 5 is equal to y. It's all looking familiar. Again, this is why we're bulldozing through this all in one day and basically take a test next class period because, it ain't too bad. Probably your most difficult kind of problem are going to be these story problems, where you have to build a system of equations from the story problem. So let's read this one. It says, when flying in still air, i.e. no headwind or tailwind, with its propellers rotating at a particular rate, a small airplane has a speed of s kilometers per hour. With the propeller rotating at that same rate, the airplane flies 473 kilometers in 2 hours as it flies against a headwind. And then 887 kilometers in 3 hours flying with the same wind as a tailwind. Find S and the speed of the wind. So I would identify my variables. So I'm looking for the speed of the plane, and I guess that's like in still air, right? And then the speed of the wind. So far, so good? Okay. So if I'm flying against the wind, I'm going to have, is the wind going to be slowing the plane down or speeding it up? Slowing it down. Right? And then we know that distance equals rate times time. That should be a familiar like middle school science thing.
Yeah.
So this is my rate. What's my time here?
2 hours.
And the distance is that, right? Now if I'm flying with the wind,
Be faster.
it would be faster, so that wind would be pushing. So that's my speed, or my rate, and then 3 is my time, and we went 887. And now I have my system, and it's just pick your method from here and go. Do we need to solve this one? I feel like we're probably good, right?
Yeah.
All right, so those are some basic algebra review, some even more basic algebra review. I find this order that the textbook does this is very surprising to me, and it doesn't make a lot of sense, but hey, I don't write textbooks for a living, and I did a better job than these jokers did. But here we go. So we're talking about relations and functions. Remember, this is the most fundamental basic relationship in algebra. So a relation is just a set of ordered pairs. Okay? A mapping diagram is a visual way of representing a relation, where you have like one set of elements in it, and then you have another set with elements in it. You connect the elements from one set to the other set with an arrow that shows how they're paired together. Everybody remember those things from like Algebra 1 or 2? I think you do it in both places. The input is the set of the values, basically the domain of our function, and the output is like the range of our function. So what's the definition of a function? You guys should all have this stone cold memorized. A function is a relation where every member of the domain maps to exactly one element in the range. Is this a function?
Yeah.
Yes. Right? Again, domain and range. Everything in the domain goes somewhere. Don't do that. Right? And they only go one place. Is this a function?
No.
No. Is that a function?
No.
Yes.
Yeah.
Does it matter that there's an unpaired element in the range? Not even a little bit. Is that a function? No. The unpaired element in the domain matters. Okay? Function all about the domain. Range doesn't matter what's going on over there. Everybody good? Okay. So just some examples. We're going to decide is it a function or not. First example here. What do we say? Function or not?
Yeah.
Lucy says yes. Good. Again, all we have to look at are the domain elements. Everything has an arrow coming out of it, just one arrow coming out. That's all I care about. Next one, is that a function? No. Why not?
2 and 5 have not.
Perfect. Yep. How about this one? Is this a function? Kevin says yes. Why, Kevin?
It's because it doesn't have two x values anywhere.
There's not a x value that is paired with two y values, right? What would that look like graphically?
It would have like a line that would go over another part.
Yeah, they'd be like stacked on top of each other, right? So one way that we check whether a graph is a function or not is with a vertical line test.
Yeah.
So again, for this function, no matter how I draw a vertical line, it's never going to intersect the graph more than one time. That passes a vertical line test. As opposed to the next one, which does not pass a vertical line test, so we conclude that that is not a function. How do you guys feel on function, not function? Hopefully pretty good, right? That's easy. So let's practice like writing some functions. So part A says express the volume V of a cube as a function of the length E of each edge. So I want to say V of E is equal to, so that's me expressing the volume as a function of E. And what would I say there? How would I compute the volume for this cube? Basic geometry fact. I'm asking you to recall. Volume for a cube.
It's C plus C squared.
What's that?
Length times width times height.
Length times width times height. What is the length in this case?
It's C or E.
E. What is the width?
C.
That's an E still.
Oh, okay.
And what's the height?
E.
So E times E times E is? Great. Done. There's our function. No big deal, right? Part B says express the total surface area of the cube as a function of the length of each edge. So I'm going to write S of E, right? What is the surface area? What does that mean?
All is times
It's the area of each surface added together.
Yeah.
How many surfaces are there on a cube? 6. What are all the surfaces the same size?
Yes.
So I'm just going to find the area of one of them and multiply it by 6. Everybody good with that plan?
Yeah.
What's the area of one of those surfaces?
E squared.
Great. So our formula then is
6e squared.
6e squared. Done. Easy peasy, right?
Yeah.
Okay. Let's do some domains and ranges here. Actually, just domains apparently. So if I look at the first function, that set of ordered pairs, what is the domain? Domain is a set, right?
Yeah.
How many numbers are going to be in that set? Infinite or finite? Finite. So if I have a finite number of elements, I'm going to use just like a set. What are the elements in this set? The domain is X or Y. X. So I'm just going to list the X coordinates. What do I have to be careful about? Does the order that I write them matter?
Yeah.
No. What does matter is no repeats. So if this was not a function and there was an X coordinate used more than once, when I write my domain, I only write it one time. B, volume of a sphere is V equals 4/3 pi r cubed. What is the independent variable in that function? V or R? No.
R.
The independent variable, or the dependent variable is usually the one by itself.
Okay.
Because it depends on the other,
Yeah, that
right?
makes sense.
Okay. So R is what we have to consider for the domain, correct?
Yeah.
Okay. What are the possible values for R in a sphere? How many is this list going to be finite or infinite? Infinite. So we're going to use interval notation to describe this. So I'm going to just say like R is a member of the set, and then I'm going to use like an interval notation. What is the smallest possible radius that a sphere can have?
Anything greater than 0.
Okay, so we'll do that. Remember the parenthesis means not included, so that's going to be the first number after 0. And then as big as a sphere as you can build, or big as radius as you want, you can build a sphere, that's fine, right? Pretty good? We're going to assume that a point is not a sphere. Everybody agree with that?
Yeah.
Radius 0 would be like a point. That's not a sphere. Okay. Domain for C. So that's again going to represent all the x values that I can plug into that function and still get a y to come back out, right? What do I have to be careful about here? What x values am I going to have to worry about? Because the x is in the denominator of the fraction, I have to worry about where x, well, when the denominator becomes 0.
Oh, yeah.
Everybody's okay? What x value is going to give us a 0 denominator there? 3, right? Because 2 times 3 is 6, and 6 minus 6 is 0. Everybody's okay? Are there any other x values that will make this function undefined? No, man, right? Okay, so I just need everything except for 3. How do I write that as a set? Or using interval notation, how do I write that? Everything except for 3. I give infinity up to 3, union 3 to positive infinity, making sure I use parentheses opposed to brackets, because the 3 is not included, and the infinities are never included, right? Because it's not actually a number. Okay. D. So here we have y equals the square root of 3 minus x. Again, finite or infinite. The x's that I can number of x's that I can plug into that and still get a y to come out. Dude, it's infinite, right?
Yeah.
You know, you have like 0, 0.0 or 0.1, 0.001, 0.0001. You know, like you see already, I can create an infinite list there pretty easily, right? So again, we're going to use interval notation. Now, can I plug any x into this and still get a y to come out? What do I have to be worried about when I'm taking the square root of a number? What kind of numbers can't I take square roots of? Negatives, right? So I have to make sure, so if I look at this, what's the biggest possible value of x I could have? 3, right? Because if I get bigger than 3, what's going to happen? X minus 3 is going to be negative. Or, sorry, 3 minus x would be negative, right? Now, if x is equal to 3, what happened? What do I get? 0. Is the square root of 0 okay? Yes. So here I should use a bracket. And then how small of a value for x can I have? Is negative like 10,000 okay?
Yeah.
Yes, because 3 minus a negative 10,000 is plus, and as long as it's a positive number, I can squirt the heck out of this thing. So this is going to go all the way down to negative. You guys feel good on how we kind of work those out? Right. Domain and range here for this one. Infinite set for each. Hopefully that's clear. Everybody's okay with that? Okay. So here I have another square root. What do I have to worry about in square roots?
Negatives.
Where the value under the square root becomes negative. When does that happen? What's the boundary value between negatives and positives? The boundary value of x. When do I get a 0 under there?
2.
2. Okay. Do I want the x's that are bigger than 2 or less than 2?
Less.
The values that are less than 2 are going to give me negatives or positives? Negatives. Do I want the values bigger than 2 or less than 2? Bigger than 2. Everybody okay there? So now let's think about the y's. So the smallest x I can plug in is 2, right? When I plug 2 in for x, what y comes out? Look at the whole function though.
Oh, 1.
1. Okay, if I plug in, say, let's pick another one, maybe I plug 6 in for x, what comes out? 3, right? 6 minus 2 is 4, the square root of 4 is 2, 1 plus 2 is 3.
Yeah.
What's happening as I plug in bigger values of x to y? They're increasing as well. Do you think they're going to increase forever?
Yes.
Yes, because as I keep plugging in bigger and bigger x's, the number that comes out of the square root is going to keep getting bigger and bigger and bigger. So 1 to positive. So we just had to decide if 1 was going to be the start or the end, right? Okay. Let's look at this one. Somebody give me the domain here. Everything except for two. Why is 2 a problem? Because it makes a 0 denominator, right? Okay? All right. So for our domain, we're missing all except for like one number, right? Our range, probably the same thing, everything except for one number, right? Who can look at this and tell me the one number that the range is missing? It's not 2. Not 1. It's usually harder to see it. It's 0.
Okay.
Why is it 0?
Is that really negative?
If I plugged a 0 in for y, So I have 0 equals 1 over x minus 2. I try to solve that for x. I multiply both sides by x minus 2, and then I have 0 is equal to 1. No solution to that. Right? If you have a variable in the denominator, that's it. There's nothing else. Setting it equal to 0 is a problem. You might also remember that from your Algebra 2 course, that this is like the form for a simple rational function, where like x equals h is your vertical asymptote, and y equals k is your horizontal asymptote. That's your horizontal asymptote, that's where the y is missing. It's almost like this stuff matters that you learned at one point.
Yeah.
Oh. All right, last one, rut-row raggy. That's got a lot going on there. So here's what I'm going to do. Is we know that because it's a fraction, that the denominator cannot be 0, right? And because we have a radical, we know the stuff under the radical has to be greater than or equal to 0. Everybody's okay?
Yes.
Okay. If I square both sides of this equation, I have that this cannot equal 0, right? So that allows me to be like, okay, well, it has to be strictly greater than 0. Is everybody okay with that?
Yes.
All right. Who remembers how to solve a quadratic inequality? This is something you would have done in Algebra 2. I think the easiest way to do this would just be looking at the graph. So if I graph 9 minus x squared, it's going to look like that. How do you know it's going to be a parabola? X squared. How do I know that the parabola is pointing down instead of pointing up? It's negative x squared. How do I know the x-intercepts are negative 3 and positive 3?
That's where.
Yeah, I said x squared, or 9 minus x squared equal to 0, and then solve. Just subtract the 9 from both sides, divided by negative 1, square root both sides, you get plus or minus 3, right? Is everybody okay then? All right. So that's that. So where is it bigger than 0? From negative 3 to positive 3. That's my domain. Everybody okay there? The range is tough. So what value do I know is not going to be in the range using the same logic as I did last time? 0.
Yeah.
Right? Because if I try plugging in 0 for this and try to solve, I'm just going to get 0 is equal to 1 again, right? So I know what 0 is not in my domain, okay? So the values of x that can come out when say 3 is close, or when x is close to negative 3. So think like negative 2.999999. Okay? I'm going to square that, I'm going to get almost 9, right? The square root of some little tiny number like 0.000001. When I square root that, so you can get bigger or smaller? Smaller.
Oh, wait.
Right? Still be like 0.000 something really small. 1 divided by something tiny like that, like 0.001 is bigger,
Yeah.
right? How big? Maybe infinitely big, right? So I think you can have that. Now, for all these domain and range problems, what else could you do to make your life easier? What if we just graph this and look at the picture? Unfortunately, this is giving me a little bit of an illusion. Because if I picked like, oops. You know, something like this, that's still in the domain. Look at the y coordinate that's on that. Really what's happening here is you're getting a vertical asymptote, and the graph, the calculator is just doesn't have enough resolution because it's getting steep so quickly to deal with it. So you do have to use a little bit of common sense there. But I think if you just did like, you know, the trace command, oops, went the wrong way. Oh. Oh. There we go. So if I'm just tracing, oh, it's dumb. Anyway, that didn't work very well. All right, last thing we want to talk about are inverses. What does an inverse do? Undoes a function, right? It just returns back. So if I have a mapping diagram, how do I write its inverse? Well, I just swap the x and y's. So here 0 went to 5, or sorry. So 5 goes to 0, so 0 goes to 5. 2 goes to 1, so 1 goes to 2. 1 goes to 2, so 2 goes back to 1. 2 goes to 3, so 3 goes back to 2. And then 5 goes to 4, so 4 goes back to 5. Right. So just basically reverse the direction there. When does an inverse exist? So we should really say, when is an inverse a function? Does anybody remember? If f is 1 to 1, then f inverse is a function. That's the rule. What does 1 to 1 mean? Means there's no repeated y coordinates. So graphically, f needs to pass a horizontal line test to guarantee that f inverse is a function. Which should make sense, because what are we really doing when we create an inverse? We're swapping the x and y's.
Yeah.
So if the horizontal line in f becomes a vertical line in f inverse. Does everybody feel okay?
Yeah.
Okay. All right, whatever. So the domain for G is this and this, right? Again, we can just use like, this is not a simple rational function because I have an x in the numerator, right? What's the rule for our horizontal asymptotes or vertical asymptotes? What do we have to look at? the degree of the numerator and the degree of the denominator. If those degrees are equal, you have a horizontal asymptote, and its equation will be leading coefficient of numerator over leading coefficient of the denominator, right? And my vertical asymptote is going to be where the denominator becomes 0. So that's what we're seeing here. If we swap the x's and y's, what's going to happen with F inverse? Where should my horizontal asymptote will become a vertical asymptote, and my vertical asymptote will become a horizontal asymptote, which means that my domain for my inverse should be the same as the range for my function, and the range for my inverse should be the same as the domain for my function. So all we're doing is swapping x and y's. Blah, 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 blah. Does everybody feel okay there? So your homework assignment for chapter 2, I'm just going to ask you to do the review. There were 3 sections in there. Rather than doing each section's homework, just do the review. We did this all in one day. For next class, I need these quizzes back. I'm going to give it to you as a take-home. It's basically just some nice free points you get to take home. You look at the notes, you can look at the book, you can look things up. You can be careful, take your time. The test is basically going to be the same thing as the quiz. So again, the test description is on the OneNote. It's basically going to look real similar to this. This is like a study guide basically for the test. Should be no big deal. I don't think there's any inverses on this, just as a heads up. So the inverses would be the only thing that would be on the test. It's not on the quiz. But that's it. This is me trying to catch up for giving you guys no homework on those 2 snow days where just like studying for the test.
How long?
Like the same. It's like 7 pages. Part of it is like,
He's just said this is a study guide for the test. It's gonna be exactly like this.
part of it is like, if I want you to draw like graph a line, like takes up a bunch of space to do that.
It's basically gonna be this, but different problems, but like the same concept.
Plus inverses. Right? Inverses aren't on this, that would be on that.
I have my worst.
They're taking a dot skill that look like.
I landed, I'm like,
You fell?
Jamie and I.
you missed it. I was talking about.
And trying to get on this paper at the same time and like hate it.
So I was planning on taking your test and I'm like,
It's not that bad. I know, I never
Same
seen
day,
it.
it's not now.
Yeah.
There's someone else.
So,
Wait, what did you
no,
do?
Mr. Everett, like,
I grew up.
you won't let you.
No, I did not know this. Okay,
First
after
off,
Michelle, first of all.
It didn't say
She
you.
wants
I know.
to, she wants to last
Email
time. I know,
down.
but this makes
That's
it
like
so that this last year.
And then on top of that, I'm going through the
So
quiz,
this is what I
and then like departments
and then this is my
asking
actual
questions,
and I wrote it.
doing my best to answer.
I didn't even write it. Okay, I just didn't know if you had to or
These
not.
3 problems.
I just asked Kate and she said she didn't, so I was like, okay, I'm not doing that.
What's your analogy?
I said it's a school.
And you got this
Yeah, I don't really know what
numbers,
you wanted. It was like the most confusing thing. I know most of my
Mr. Everett, I got you. Like, I can't, you can't even hit up.
Oh, yeah, when you want to leave us up.
Oh yeah, I have used done too.
Yeah.
You never
I'm like,
I was happy, but like,
that's what my math test on Friday. And I'm like,
Yeah.
this entire time, I'm like, Email Mr. Myers.
I know.
Like 30 minutes before school started. I knew he was in or would be in the room. Check shit out. You never answer the email, never send Mr. Emmer. You guys, Mr. Emmer can go down and have all this crap. I'm like, I just spent as much time as I would have had to take.
I
didn't go to
Can I grab one of those?
But like, that was. I know, he already
Oh, wait, yeah, we have class Friday. Wait, so it's the test Friday then?
Yes.
Oh, right.
And I feel like it's.
Do it at home. Do it at home.